All right, this is 11A notes. We're going to be looking at an introduction to our trig functions. Hopefully a lot of this will be review from geometry. So first of all, let's see, remember, what does the word SOHCAHTOA mean? Do you remember SOHCAHTOA? What does it mean? Hopefully you remember that it's a way of remembering the trig ratios. All right, so remember we read this as sine of theta. So this is abbreviation. SIN is abbreviation for sine. COS is abbreviation for cosine. And TAN is abbreviation for tangent. These are ratios for our different angles theta. So let's look at that ratio. So in a right triangle, and our trig ratios only work for right triangles. All right, you got your right angle. The side across from the right angle is the hypotenuse. All right, we're looking at this angle theta, so we call this side our adjacent side, and the side opposite, of course, is the opposite side. So sine. Sine ratio is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So those trig ratios. Okay, so let's look at an example. We've got the right triangle, 3, 4, 5 right triangle, one of your Pythagorean triples, and we want to find the sine, cosine, and tangent of theta. So we're in reference, our reference angle is our theta. So in this case, our 5 is our hypotenuse, our 3 is opposite, and our 4 is adjacent. It's all in reference to that angle that we're looking at. So when we set up the sine ratio, we're going to go sine of theta is equal to opposite over hypotenuse, so 3 over 5. The cosine of theta is equal to adjacent over hypotenuse, so 4 over 5. And the tangent of theta is opposite over adjacent, so 3 over 4. All right, so here's a summary of all of our trig ratios. Now here's what's new. We're going to add 3 new trig ratios. All right, and notice that these are reciprocals. So cosecant is the reciprocal of sine. So it's going to be hypotenuse over opposite. And secant is the reciprocal of cosine. So it's going to be hypotenuse over adjacent. And tangent, or cotangent, is the reciprocal of tangent. So it's going to be adjacent over opposite. The way I remember who goes together is like the letters of the opposite. So it's S and C, so sine and cosecant, cosine and secant, and of course tangent and cotangent are easy to remember. But they're just reciprocals of each other. So we have 6 trig functions total. So here's the Algebra 2 trig part of it, is adding those 3 new trig functions. All right, so let's look at applications of this. So here's our first question. If we know that the tangent of theta is equal to 6 over 7, we want to find the other 5 trig ratios. All right, so let's set up that right triangle. So we've got a right triangle. All right, it's marker theta. So if tangent is opposite over adjacent, so that means the 6 is the opposite side and the 7 is the adjacent side. So in order to set up our trig ratios, we now need to find the hypotenuse. Remember here, we're going to use the Pythagorean theorem. So h squared is equal to 6 squared plus 7 squared. So h is equal to the square root of 36 plus 49. So h is equal to the square root of 85. All right, and 85 we can't break down, so we're going to leave it like that, the square root of 85. Here, like I said, this is geometry again. So typically when we solve a quadratic equation, we want plus or minus, but this is geometry, so this is a length. So that's why we only take the positive one. So we're not throwing away our Algebra 2, it's just application here because it's a length. All right, so we want the other trig function. So we've got tangent of theta is equal to 6/7. So that means the cotangent of theta is the reciprocal, so that's 7/6. We want the sine of theta. So sine is opposite over adjacent. So in this case, our opposite is our 6 and our adjacent is our 7. So sine is going to be opposite over adjacent. So 6 over the square root of 85. All right, we should rationalize that. So that's going to be 6 square root of 85 over 85. All right, we want the cosecant of theta, which is a reciprocal of sine. So that's the square root of 85 over 6. All right, and that leaves us with cosine of theta, which is adjacent, 7 over the square root of 85. Let's rationalize that. And then finally, we want the secant of theta. So that's the reciprocal. So square root of 85 over 7. So that's what we mean by this when we set up the trig ratios. Find the value of the trig ratios. And we can change them to a decimal. Typically, you leave them as a fraction, though. All right, another type of problem you're going to have. All right, remember the special right triangles, our 30, 60, 90, and our 45, 45, 90. Remember from geometry that these have special patterns, and we're going to use this a bunch in our trig, these special right triangles. It's going to be a whole unit that we're going to devote to our special right triangles. So recall that in a special right triangle, the short leg is across from the smaller angle, our 30-degree angle. This is our 60-degree angle. That's the side to know. The short leg is the one you want. So I'm going to call that x. Well, to find the hypotenuse, we double our short leg, so that's 2x. And our long leg is x square root of 3. And here again, like this is coming from the Pythagorean theorem. Like I said, that the proof of this, if you didn't do that in geometry, we can talk about that later. All right, in a 45, 45, 90 triangle, it's also called a isosceles right triangle because the legs are congruent. We're going to call the legs x, and the hypotenuse is x square root of 2. So we're going to use, instead of, like I said, using the Pythagorean theorem or our trig ratios, we're going to do shortcut here. Like I said, trig ratios will give us an approximate answer. These are going to give us exact answers. So look at the examples that we have. So we have a 30, 60, 90 triangle. This is my short leg. So that's 9 is my long leg. So look back at our formula here. Our long leg is equal x square root of 3. Well, I want to find x. The short leg is the one to know. So I'm going to solve for x here. So I'm going to go 9 divided by the square root of 3 is equal to x. Well, we know we don't leave a radical in the denominator, so we're going to rationalize this. So that's going to end up being 3 square root of 3. That's going to be our x. And then to find our long leg, we just double our short leg. So our hypotenuse. To find our hypotenuse, we're going to double our short leg. So 2 times 3 square root of 3 is going to give us 6 square root of 3. Okay? All right, let's look at the next example. This is a 45, 45, 90. So I know that these two legs are going to be congruent. All right, back at our formula, all right, or back at our up top up here. All right, this is the hypotenuse. That's x equal, I'm sorry, not x equals, try that again. X times the square root of 2 is equal to 1. All right, let's solve for x again. So x is equal to 1 over the square root of 2. Let's rationalize. So that leaves us with the square root of 2 over 2. So that means our legs are square root of 2 over 2 for each of these. All right, 45, 45, 90 again. All right, what do we have? We have one of the legs. So we know we're going to multiply to find the hypotenuse. So this leg is going to be 3 square root of 2, 2. We're going to multiply 3 square root of 2 times the square root of 2, which gives us 3 times 2, which is 6. All right, our last example on special right triangles. All right, this is a 30, 60, 90 triangle. Notice this is the hypotenuse. We want to find the short leg first. Always find the short leg first. Well, looking back on the previous page, the hypotenuse is equal to twice the short leg. So that means that x is going to equal to 1/2. So what's the long leg? We take the short leg and multiply by the square root of 3. So that means our long leg is going to be square root of 3 over 2. You're going to see these patterns when we have the hypotenuse being 1. We're going to use this a lot later on with the 30, 60, 90 and the 45, 45, 90. Okay. All right, we want to solve the right triangle. What does that mean? That means to find the measure of all the angles and the length of all the sides. All right, that's what it means to solve a right triangle. So let's do that. Let's set this up. Like I said, this only works for a right triangle right now. You'll learn how to handle other kind of triangles when you take for next year. Okay, so let's find that. Let's get rid of our writing here and start. Okay, so we got our triangle. Put in a right angle. Now label your triangle. Let's label it A, B, C. All right, so remember back from geometry, angle side A is across from angle A, side B is across from angle B, and side C is across from angle C. All right, now this is not drawn to scale. So angle A is 49 degrees. So if we set it up this way, that's going to make our A our opposite, our B our adjacent, and our C our hypotenuse. All right, so let's find our angles first. Those are the easy ones. Right, hopefully from geometry again, the sum of the angles of a triangle is going to be 180 degrees. We already have angle A. All right. Angle B is, we need to find, and angle C is 90 degrees. All right, angle B. We know, since like I said, that's 90 degrees, so that means A plus B must equal 90 degrees. So that's going to leave 41 degrees for angle B. So finding the angles are easy. The sides are going to be a little bit more work. Let's find the sides. We're going to use our trig ratios to find our sides. All right, we need to start with one of them. Let's find A. All right, and we know that C, let's put that what we know in. We know that C is 27, so we know that that's given. Okay, so using angle A, let's find side A. Okay, so what trig ratio are we going to use? So we've got A is opposite, and we've got the hypotenuse, so that means we want to use sine. We're going to use sine. So set it up. Sine of 49 degrees is equal to the opposite, which is our A, over our hypotenuse. All right, we're solving for A. You can think of this as being like a proportion, cross multiply. So A is going to equal to 27 times sine of 49 degrees. All right, we're going to put that in our calculator. You can look it up on the chart or put it in the calculator. Typically we use the calculator nowadays. So look at your calculator. Now here's something you have to make sure that you do on your calculator. Hit your home button, go to settings, otherwise you're going to get the wrong answer here. Go to number 3, handheld settings. Nope, not there. Let's find it again. So we're going to settings, document settings. Here we go, document settings. We want to change this angle measurement to degrees. The default is radians, and we'll talk about what a radian is later on. We're going to learn what a radian is. So we want to do our angle. We want to make sure that's in degrees. So hit OK on that. All right, now we can go ahead and type this in. So we're going to type in 27. All right, we need to find our trig. All right, see across from the 7 is our trig buttons. We want trig, and we want sine of 49. Close your parenthesis and hit enter. All right, and typically you round to the nearest tenth. Just follow the directions on rounding. So that's going to be 20.4. So the measure of that side for A is 20.4. All right, now we need to find b. Well, you have a choice for finding b. You could use the trig ratios, or you can use the Pythagorean theorem. Since we're practicing the trig ratios, let's do that. So we're going to still use our reference angle of 49 degrees, and we want to find b. Well, which trig ratio are you going to use? Well, you see you've got adjacent and you've got hypotenuse. Always use what's given in the problem. Don't use your rounded answer because it's going to throw that off. So we want to use that 27. We don't want to use that 20.4 that we just found. All right, so what trig ratio is adjacent hypotenuse? Adjacent over hypotenuse. Hopefully you set cosine. So we're going to set it up. Cosine of 49 degrees is equal to b over 27. All right, here again, solve for b. So we're going to cross multiply, so 27 cosine of 49 degrees. And we're going to put that in our calculator. All right, if you haven't reset your calculator, it's going to stay in degrees. So we're going to go 27, hit our trig again. This time we want cosine of 49 degrees. And hit enter. And we're going to round to the nearest tenth. So 17.7. So b is 17.7. So now we've solved our right triangle. We found all the sides and all the angles. All right, let's look at a couple of word problems. You're hiking toward a main road. All right, so here's our road. We're hiking toward a main road. You reach a point where the road is flooded. To avoid the flooded area, you turn onto a diagonal road that meets your original road at 48 degrees. So you're traveling along and you're going to have to take a diagonal road. This is 48 degrees here. And follow it for 3.6 miles. So that's 3.6 miles. How far from the main road were you when you turned onto the diagonal road? All right, so we're going to be looking for this distance here. That's our unknown. That's our x that we were looking for. All right, so how are we going to set this up? Look at what we've got. Here's our reference angle that we're using, our 48 degrees. So in terms of what's our missing side? That's our opposite side from 48. And of course, our 3.6 is our hypotenuse. So what trig ratio is opposite over hypotenuse? If you set sine, you're right. So we're going to set this up as sine of 48 degrees is equal to our opposite over our hypotenuse. All right, here again, we need to solve for x. So we're going to cross multiply and put that into our calculator. So 3.6 sine of 48. And hit enter. All right, and it's around to the nearest tenth. So 2.7. And make sure you put your units, so 2.7 miles. All right, let's look at another word problem. From a point on the ground 28 feet from the base of a flagpole, so we got a flagpole. All right, from a point on the ground 28 feet, so the point out here that's 28 feet away, the angle of elevation to the top of the flagpole is 63 degrees. So this is 63 degrees. What is the height of the flagpole to the nearest tenth of a foot? So we're looking for this. Height of our flagpole. Here's our right angle. Okay, so what do we got here? What do we have? Our x in reference to our 63 is our opposite. And the 28 is our adjacent. So which trig ratio is opposite over adjacent? All right, hopefully you said tangent. So we got the tangent of 63 degrees is equal to our opposite over our adjacent. Here again, we're solving for x. We're going to cross multiply. All right, so let's put that in the calculator. So we got 28 tangent of 63 degrees And we'll round it to the nearest tenth. Well, that's going to round, so 54.95. 5 is going to round the 9 to a 10, so it's approximately 55 degrees. So we got x equals 54.95, but following direction, this is approximately 55 feet. Okay. All right, let's go back for a moment. We haven't done a problem where we have to go backwards and use inverse to find an angle. So let's go back to our problem early on in our notes here. Let's suppose I want to find actually what the angle theta is. I can use the trig ratios to find the measure of angle theta. So if I'm trying to solve for theta here, let's do this. We'll use the sine of 3 over 5. If I want to know what theta is, I'm going to use the inverse sine. So theta is equal to inverse sine of 3 over 5. This is going to give me my angle measurement. All right, let's see where that is in the calculator. We're going to put that in the calculator. So basically what it's saying is what angle has a sine of 3 over 5? All right, so if you go to your trig again, see at the bottom row, there's our inverses. That's when we want to go backwards and find an angle. So we're going to use sine to the negative 1, inverse sine, and you're going to put in your fraction, 3/5. Make sure it's all in the parentheses, so 3 over 5. This is going to give us an angle measurement. So hit enter, and typically you round angles to the nearest degree. So this is going to be approximately 37 degrees. So approximately 37 degrees. Now we can see it doesn't matter which trig ratio we use. Let's do the same thing with cosine or tangent of theta. Doesn't matter which one. We should always get 37 degrees for that theta. So let's make sure. Let's just, hopefully, like I said, don't believe always what you're told. You want to see it. So theta is equal to the inverse cosine of 4 over 5. So let's put that in the calculator. So inverse cosine, and we want that fraction again, of 4 over 5. And here again, see, we're getting the exact same angle. If we did tangent, all right, what was tangent? It's going to be 3 over 4, right? 3 over 4. And here again, same angle. All right, so it doesn't matter which trig ratio, we're still going to get that angle of about 37 degrees. All right, please, if you have any questions, ask in class, and I'll see you in class.